Dimensional analysis is a physicist's shortcut that feels like a magic trick, but it is only bookkeeping. Every quantity carries units: length, time, mass, charge. If an equation is true, the units on the left and right must match. That simple rule can reveal the shape of an answer before we solve any detailed equations. Suppose you drop a ball from height h. What controls the fall time? The height h has units of length. Gravity g has units of length per time squared. We need a time. The only combination with units of time is the square root of h over g, so the answer must look like t equals a pure number times square root h over g. The missing pure number depends on details, but the scaling is already forced. Double the height, and the time does not double, it grows by square root of 2. The same idea organizes more complex science. A pendulum's period can depend on its length L, gravity g, and maybe the mass m. Units say mass cannot matter, because there is no other mass quantity to cancel it. The natural time scale is square root L over g. Dimensional analysis is not a replacement for dynamics. It cannot give every constant, or decide between effects with the same units. But it is a powerful error detector and intuition engine. Before trusting a formula, ask, do the units balance? If not, the universe is telling you the equation cannot be right.